Okay, so just to follow up on the previous video about setting force charge windows, there's been a few questions around what the options mean, what minimum state of charge means, and what should I have it set to, as well as um, EV owners asking for best practices around charging EVs and preventing discharging from the battery during cheap overnight rates. So I try and bundle answers and best practices tips into one video. Talks about sort of everything you need to know about your Fox's battery management and what settings have what result, and some of the tips and tricks that I've learned after being a Fox's owner for a couple of years now, also being an EV owner and driver. So we'll jump straight into it. So this is a just a screenshot of the initial video where I was walking folks through how to set the force charge window. Um, there's really three main options, and how you get to this on the desktop version through foxcloud.com is in the top right where I'm circling now. You'll see the settings cog, that red icon that will pop this window. If you're using the mobile app and not the desktop, then you'll go to battery, and then in the corner you'll see what looks like a sort of symbol of maybe an eye or something like that. Click that symbol and that will bring up the battery management and charge sort of management control window, both on Android and iOS. When you're in that screen, you'll notice the three main options, and this is the same for the desktop as it is for both Android and iPhone. You have an initial charge window, you have a second charge window, and you have a third charge window. Sorry, first and second, and then you have the state of charge settings. So what does this mean? Right, well, most people who have invested in a solar system also have batteries. The Fox system is sold both as just a solar inverter, but also as a hybrid inverter where you can then attach batteries to the system. One question we see a lot: how many batteries can I have? Just to let you know, the minimum is 2 battery packs, one BMS going to a H series inverter. So a H1, H1 3, 7, 5, 6. Normally they've got an E on the end of them as well in most of these model numbers. But if you've got a hybrid inverter, you can have from 2 batteries, the maximum of 8, with kind of most people's return on investment being around 6 to 7 batteries, which is typically the recommendation depending on your use. So if you've got batteries, you've got solar, that works great. During the day, your solar is charging up your batteries for your evening time use. If your house loads exceed the generation of the solar, the batteries are going to help support the house load by discharging the batteries to make up the solar shortfall even during the day. This all works great. The Fox's inverter is able to blend the grid, the solar, and the battery seamlessly. There is a slight response time that happens. So if you turn the kettle on, that's a high kilowatt device, you'll notice that uh, the Fox will take maybe half a second or a second to respond to that. So it will draw from the grid just for a moment, and then the batteries and the inverter will respond, and then your grid uses will go back down. While we're on the grid usage, the Fox inverter has a G98 and a G99 safety standard, which means that it has to be monitoring the AC power coming in from the grid, and if there's a grid fault or a grid outage, the inverter shuts down to prevent backfeeding onto the grid. It's by design, but because of that design, it means that it uses the CT clamp, the white box clamped around your incoming cables in your meter box. It uses those as a floating point device, so it knows how much discharging to do out of the batteries or from the solar in order to keep up with the house demands. It does that, and it deliberately slightly shorts how much it's giving to the house by about 20, 30, sometimes 40 watts. So you'll notice if you've got a smart meter with an in-home display, even on sunny days, you're still using 20 to 30 watts from the grid. That's absolutely normal, and that's going to be the case unless you're exporting where your batteries are full. Then you'll notice just pure export. That small usage in power is there as a safety system so that it can monitor the grid connectivity. Absolutely fine. Back to the charge windows. If you have a cheap overnight rate, such as an Octopus Go, you normally have a window of cheap power. During the daytime hours, it's normally very expensive, and that is significantly reduced as part of the sort of financing model that you might have gone through where you're trying to figure out, well, if my overnight rate is very cheap and I have batteries and solar, I shouldn't be using much peak power. So the financial model that you've put together to figure out, well, is this worth it or not? Should I have batteries? How many batteries? How many solar panels? For most normal houses, having some batteries and using an off-peak tariff like an Octopus Go or an Octopus Intelligent Octopus is a great product. And what you do in the charge control is you can set a time window when you want to take advantage of that cheap rate electricity to charge your batteries. So in this example, in this first box, this is what it would look like set up in order to force charge your batteries from the grid during this time window. So from 12:31 a.m. to 4:30 a.m., I am force charging the batteries with this option, and I am enabling charge from grid, so I'm going to consume grid power. What that means is while the batteries are charging, they won't be discharging. The house will be also running off the grid, so your house is taking advantage of that cheap rate electricity at the same time that your solar system, your solar Fox's battery system, is charging from the grid. When it reaches 4:30, the expensive electricity rate then starts, and the Fox's system stops charging and starts providing, covering the home's usage until you either run out of power, in which case it will go back to the grid, or when, as the sun starts to rise in the morning, you'll then start to top those batteries up again. And during sunnier days, you get multiple sunny days in a row, you're really just not charging your batteries very much because you're still ending the day with quite a high level of charge. So that's great. Well, a couple of questions around the next sort of natural step as well. How do I stop the batteries from discharging during this cheap rate, because this rate is very cheap, and I want to charge my electric vehicle, so I want to stop the battery discharging, and I want to charge the vehicle from want to charge the vehicle from the grid, but I don't want to charge the batteries because I'm going to have a sunny day tomorrow. So in that scenario, so just to reiterate, this example is great if you want to charge the car, charge the house battery, and run the house off of cheap power all at the same time, because the battery can't be discharging whilst it's being charged. The next scenario is you want to charge the car, but you don't wish to charge the Fox's battery system, and you don't want the car to discharge the battery system. So when you wake up in the morning, your battery's empty, you've been consuming premium electricity, the peak rate electricity, and you've also put additional wear on that battery by completely emptying it overnight, really for no reason. So the best way to do that, to charge your electric car and not charge your battery system, is to simply disable this option here. So the enable charge from grid option means that you've got a force charge window enabled with this first option, which means that between these times, the system isn't going to be discharging power. If it is, it will be a very small amount just to manage the batteries if they're doing a rebalance or anything like that. But between these times, with this bottom option turned off, means it can't consume power from the grid, but it also is set to only charge. And at night, there is no sun, so it's not charging. So it's not discharging and it's not charging. It's effectively just in suspense between these times, which is exactly what you want if you just want to charge your electric vehicle and move your house loads, such as washing machines, dishwashers, all of those devices, between these hours to use that cheap rate. It also minimizes the wear on your house battery. So that's as simple as it is. If you want to charge your house and your car, you have both these blue options checked. If you only want to charge the car and not charge the house battery, uncheck this bottom option and hit save. And that will then mean that your car can charge without discharging your battery. The economics of charging an electric vehicle from your house battery, for me, don't make sense. I've tried a few different ways of trying to make it viable, but if you take into the account that you're putting wear cycles on your battery every time you discharge from your batteries, the cost of those batteries, and at nearly £1,000 per battery unit, they're very expensive. And batteries age through calendar aging and also through use, through cycling them through full cycles. So from 100% to 10% would be one cycle, then to charge it back up to full again. That's a cycle. Fox is currently advertising around 6,000 cycles worth of estimated life. If you're not charging your car from these batteries, then what happens is most of the time you're only shallow cycling the batteries. So the times where you use a little bit more power than you're generating comes from the battery, but then as soon as that device turns off, it starts charging again. So you're not normally doing full to empty cycles during the sunnier months of the year. Shallow cycles don't count as a full cycle. So your battery system will be able to do far more shallow cycles, and not just a few more. We're talking, multiple times of capability. So if you're only cycling it from 90 to 70% for half the year because the solar is so good, your battery is going to last significantly longer and do 2-3 times the cycle life as if it was to do 6,000 full to empty cycles. So that's something to consider. So if you've got an EV, most EVs are going to have anywhere from a 40 to 100 kilowatt hour battery capacity. Using the battery, you're not going to add that much range. You're just going to end up emptying the battery, forcing your house loads to then move on to the peak rate electricity. Combine that with the wear on the battery cycle, because you will be wearing it, and you'll be wearing it at an accelerated rate because it will be doing a high current discharging, which generates heat and more wear. I can't make any of those numbers worthwhile. I can't, just doesn't work for me when I try to do some modeling on it. So everyone's different. If you're charging a smaller car and you've got a car charger that supports the idea of only charging the car with surplus solar instead of exporting it, that's probably a better way to go. But if I was advising anyone on any EV owner with a Fox system, I would say try to either only charge your car from solar or charge it with cheap rate electricity overnight. Don't allow whatever configuration you've got on your car charger to be discharging the battery whilst charging your car. I just don't think you're probably accidentally causing yourself a higher cost than just waiting to use the cheap rate overnight when you take into account that battery maintenance. That's quite a long rant about that subject, but it's important that you understand how the battery cycling affects its life and how to stop your batteries from discharging if you have an EV. So that's just my take there on this screen. Of course, you can set up 2 of these windows, particularly useful if you want to stop the batteries discharging during the middle of the day, for example, should you have a cheap midday rate as well. So the Foxer system supports 2 completely independent time windows. Either can be configured to just block discharging, but only having the top option turned on, or allow complete blocking of the charging, but also charging from the grid using the grid power to the batteries by having both of those options set. At the very bottom of this page, just out of view, you'll see the state of charge down here. By default, it's set to 20% as just a conservative number for out of the box. The battery and the hardware fully support something called a depth of discharge down to 10%. So you've got 90% usage of the battery in your depth of discharge. Setting both those bottom figures to 10% is absolutely fine. The difference between minimum state of charge and minimum state of charge on grid is that these inverters can be used in power blackout situations where the power fails, and you can have it set to store extra power as a higher reserve level to cover you in the event of a power failure on the grid. It's not a particularly common set up in the UK. Some folks on the group have implemented emergency power sort of sockets in their airing cupboards and things. So they've got a set of sockets that are always powered regardless of the grid situation. That's a good idea. Some people have got separate consumer units and subboards that they're powering off of the what's called the EPS port, the emergency power supply port. That's what allows the inverter to give out power to the house through this additional port that you plug into. But yeah, this is pretty much, there's only a few options on the screen. It's not super intuitive, but there's really only two toggles you need to worry about in addition to the time. Yeah, post any questions. If you have any ideas, anything that's worked for you with using this with an EV or charging an EV. And yeah, thank you very much. Bye for now.